we have got 2 points here, one here and one here. Let's name it as A and B. This point can be named as A and this point can be named as B. Let's see this point in general. Let's take it as coordinates as x1, y1 and this coordinate as x2 and y2. This is the midpoint of A and B. So let's have this as x comma y, since we are going to find the midpoint of the line joining A and B now. In order to find that, we are drawing a vertical line towards the x-axis so that it meets the x-axis at x1, and similarly from B the line here meets at x2. Therefore this point should be x. As we can see, x is in the middle of x1 and x2. Therefore x should be x1 plus x2 over 2. Similarly, y will be the middle point of y1 and y2 if we draw a line like this towards the y-axis. This is y2, this is y1, this is y, and therefore this y is the middle point of y1 and y2. Therefore we have y as y1 plus y2 over 2. Therefore the middle point xy, which is C, can be given as x1 plus x2 over 2, comma y1 plus y2 over 2. This is the formula for finding the midpoint of 2 points x1, x2 and y1 and y2. If we have A as 5, 6 for example and B as say 3, 2, then our C, which is the midpoint, will be 5 plus 3 over 2 and 6 plus 2 over 2, which is 8 over 2 and 8 over 2. So the coordinates of C will be 4, 4. So 4, 4 is the midpoint of the line joining 5, 6 and 3, 2. In the first part, we saw that if C is the midpoint of AB, and then the x coordinate of C is given by x1 plus x2 over 2, and the y coordinate of C is given by y1 plus y2 over 2. This we found it as by saying that x here is the midpoint of these 2 points, therefore x is x1 plus x2 over 2. We can also prove this in another method. This method will help us to find the coordinates of points other than the midpoint on this line AB. Now, if you can see this, x is nothing but x1 plus this part, this length plus this length. So this one is x1 and this length is half of this. So this one is x2 minus x1. Therefore this is x2 minus x1 over 2, half of the total distance, which is x2 minus x1 over 2, and this part is x1. Therefore my total distance here can be given as x1 plus x2 minus x1 over 2. This distance, as I said, is nothing but x because this is x. So from here to here we call it as x. Therefore x is equal to this part, which is x1, plus this part, which is half of x2 minus x1. Now if you simplify this, we get LCM as 2. We can take it as 1. So 2x1 plus x2 minus x1, which is x1 plus x2 over 2. This is the same formula we got in the previous part. The same way, y can also be found as y1 plus y2 minus y1 over 2. Ultimately, this gives you 2y1 plus y2 minus y1 over 2, which is y1 plus y2 over 2. So this again gives the same formula as before. So in this way, what we are doing is we are finding this part as half of x2 minus x1 because this is in the ratio 1:1. C being the midpoint, it divides the line AB in the ratio 1:1. Therefore, it ultimately becomes x1 plus x2 over 2 and y1 plus y2 over 2. We can also find the point if the point was somewhere here, say for example C1. If the point was here, let me clear off all these things now. Now, instead of being here, if the point was here, say for example C1, which is xy, and we keep the a's and b's as it is, x1, y1, and this one as x2, y2, which is b. In this case, it looks like this: C1, which is x comma y, and A, which is x1 y1, and B, x2 y2. Now C is not the midpoint of AB, but it is somewhere in between. Say for example it is cutting AB in the ratio 1:4. How will you find the points x comma y? This is left to the readers. The C can also be anywhere. Say for example I can move the C somewhere here and say that it is in the ratio, cutting the line AB in the ratio 5:1. So this C, how will you find it? In general, we can say that if the point C cuts the line AB in the ratio m:n, what will be the coordinates of C? The proof is left to the viewers, but the answer can be given here, which is mx2 plus nx1 over m plus n will be the x coordinate of C, and my2 plus ny1 over m plus n will be the y coordinate of C.